Hello everyone, I'm Chen from Indiana University, Bloomington. This is a collaboration work involving the Institute of Information Engineering, Chinese Academy of Sciences, and WPI. In recent years, my group and I have been on the road with some awesome projects using documentation to discover and predict security vulnerabilities. Today, I'm here to present our latest work using 3GPP specifications to help produce 4G conformance tests that used to test whether the specific implementations follow the specification requirements. Recent years have seen continuous report of security weakness in cellular network, especially on the user equipment UE like mobile phones, smartwatches, and smart cameras, and other kind of IoT devices. These vulnerabilities and names can be exploited to disclose our user location, deny her service, eavesdrop on sensitive communication, etc. The disappointing thing here is that many of these vulnerabilities are actually caused by not following the 3GPP specifications. For instance, the 3GPP specification explicitly requires the UE to verify the integrity of certain messages. But recent studies have revealed that many UEs do not perform this verification, leaving them vulnerable to DOS attacks. Such vulnerability should be captured by the conformance testing, as we just mentioned, which is meant to verify whether the UE's implementation follows the requirement of the specification. In fact, 3GPP has already developed a branch of conformance tests to ensure that UE are implemented correctly. For this purpose, they've put a lot of effort, got a team of several dozen technical staff working together with various companies all over the world. But unfortunately, as our investigation, they've never been achieved their strong demands as are claimed virtually every year. For example, they only finished around 37% of the development goals set in 2020 until the end of the 2021. And every single year, more and more demands for conformance testing pop up. And the situation becomes even worse when it comes to a security-related test. Only a small portion of current conformance testings are related to security. For example, for LTE NAS protocols, there are more than 600 conformance tests, but only 9 are related to security. So, to address these problems, we believe that an automated assistance is needed to speed up the development of these conformance tests. Okay, to understand the unique challenge in conformance test development, let's look at how a test case is generated. The input for generating a conformance test is called the test purpose, which comes from the specification. It typically describes what actions the UE must take if a specific event occurs in a certain state. Like this example, the UE must take if the initiator status is in a state called EM register initiated. The condition event is when the UE receives the detach request message. And the expected operation the UE must perform is to ignore the detach request message. For such a test purpose, 3GPP first design a test procedure. This procedure is like a list of instructions that a testing system should follow. It tells the system how to get a UE to the initial test states, how to trigger the condition event, and how to check if the expected operation happens. Pay attention here, all this need to be done through the error interface because the tested system should simulate a real carrier network to communicate with the UE. Next, 3GPP develops a test suite to put a test procedure into action. As we went on this process, we found a unique challenge in step 1, the test procedure generation. You see, the testing system connects the UE through the error interface, which means it can only do limited operations with the UE, such as sending a message to a UE or observing the message coming from the UE. So here's the thing, the testing system might not be able to directly trigger the condition event or directly observe the expected operation. Here are 2 examples. The condition event in test purpose 1 and the expected operation in test purpose 2 are both internal operations of UE about timer, which means the testing system can directly trigger it or observe it through the error interface. So how to trigger such condition event and how to observe such expected abortion is the unique challenge in the test procedure generation. To handle the test purpose once condition event, the current 3GPP test procedure requires to reboot UE, causing an attach request message to be sent, which further triggers a sequence of events, eventually leading to the expiration of the target timer. So it's like a chain reaction, indirectly trigger the desired event. To verify the expected operation in test purpose 2, things work similar. This time, the testing system can determine whether the UE starts a timer by observing whether the message has been transmitted. However, when developing this kind of test procedures, a human analyst has to identify the events and the relations through a large number of conditions from the convoluted 3GPP specifications. Take the first chain, for instance. There are 25 different conditions for starting a timer and 13 for starting another timer. It gets even trickier because such multiple conditions and follow-up operations also happen to other events. More worse, most of their combinations are not on the event chain that a testing system can initiate or observed. This makes manual developing a conformance test procedure extremely complicated. So far, we found that a unique barrier to test procedure generation is to recover such a chain from the documentation. And to speed up it, we believe this needs to be done automatically. For this purpose, we come up with a technique to first automatically build a graph from the step 1. We build a graph from the 3GPP specification. We call it the event dependency graph. Second, actualize the graph to recover the chain, or sometimes the subgraph. And finally, use an event that can be directly triggered or observed along the chain to construct a test procedure. Absolutely, among the 3 steps, the establishment of event dependency graph serves as a foundation of everything. So next, let me introduce how we achieve it. Actually, we found that almost all the information we need to build a graph is well documented in the 3GPP specification. Now let's look at 2 sentences. First sentence says when the timer runs out, the UE will initiate a procedure subsequently. It is a causal relation. The currency of one event triggers next. Similarly, the second sentence also indicates a causal relation. When the UE initiates a procedure, a message will be sent next. In our research, we use semantic role labeling to capture such causal relation. It extracts a sentence semantics by labeling its key elements, telling us who did what to whom, when, and etc., like this. So using these labels, we come up with a set of rules to extract a causal relation for every sentence from the 3GPP specification. Now, let's see these 2 nodes. It's easy for human beings to see they actually have the same semantic meaning. Once we connect them, an event dependency graph from expiry of timer to sending a message will be established. However, using current NLP tools such as sentence similarity to connect nodes would introduce unexpected results. For these 2 sentences, send an attach request message and send a detach request message. Current tool might think they are super similar because they share a bunch of words. But in our graph, they are totally different actions because the transmitted messages are different. So in our research, we trained a specific model for making these connections. Well, through this way, our event dependency graph could be established. Based on it, we could do backward or forward reasoning to recover the chain automatically, find the events that the testing system can directly trigger or observe, and construct a conformance test procedure. I leave the details of reasoning algorithm and construction of the test procedure in our paper. Before I end my presentation, let me show some surprising discoveries we made while using the conformance tests we generated to test commercial UEs. We generated a conformance test procedure for 22 security requirements from LTE specification. Using them, we tested 20 mobile phones and 2 IoT devices from 10 different device vendors and top 6 major baseband manufacturers. To our surprise, our testing system caught 197 security requirement violations, and 190 of them were never reported before. Particularly, we found that 19 security requirements were violated by at least one UE. Every single UE we tested failed to meet at least 3 security requirements, and even the latest released iPhone 30 violated 7. Well, we reported all the violations to our relevant vendors and have received confirmation from some of them. The detailed information about vulnerability disclosure is updated to our website. And finally, I want to talk about some future work along this line. Our work is an attempt to use NLP techniques to extract semantics from 3GPP specification to build the event dependency graph for the purpose of automating the generation of the LTE Conformance test procedure. Down this road, a more comprehensive and precise graph could be built by bringing some advanced technique in the future. The 3GPP specification carry a wealth of information, and we've only scratched the surface. We believe with NLP-based semantic analysis, we could extract more valuable knowledge from specification for improving security assurance for senior networks. Yeah, and that's my presentation. Thanks for your time.